Hello, calculus fans! Let's find a vector function that represents the curve of intersection that we get when we take the cylinder x squared plus y squared equals 1 and intersect it with the plane y plus z equals 2. You should recognize y plus z equals 2 as a plane as it falls into the standard definition of the scalar equation of a plane. All right, let's show a picture that's going to show the plane and the cylinder intersecting along with the curve of intersection, which happens to be an ellipse. Here's a picture. So the plane is intersecting with the cylinder, and we get this curve, which is an ellipse. We're going to try to write down a parameterization or a vector function for this ellipse. So it's kind of a slanted ellipse, right? Because the plane is slanted and is cutting through the cylinder. So let's take the projection of this curve onto the xy plane. It's the circle x squared plus y squared equals 1 and z equals 0. So that's not the curve C, that's the projection of C onto the xy plane. Now, we talked about how we can write down a parameterization of this circle. We can just say x equals cosine t, y equals sine t, and t goes from 0 to 2 pi. Now let's take our equation of the plane and rewrite it as z equals 2 minus y, and since y is equal to sine t, then we'll have z is equal to 2 minus sine t. All right, so now let's write down some parametric equations for the curve. X equals cosine t, y equals sine t, z equals 2 minus sine t, and the values of t are going from 0 to 2 pi, which represents going around the circle once. If you like, you can write down a vector equation. So once you have parametric equations, it's easy to write down vector equations. And in this case also, we're going to have t going from 0 to 2 pi. Okay, that's all for now.